Hello viewers, in today's class we are going to discuss one important definite integral involving the product of two trigonometric functions, right? So here we have to evaluate this integral that is 0 to pi and sine 2x and cosine of 5x, right? So here we see that the integrand is a product of sine and cosine, right? And the limits are from 0 to pi, right? So here we'll solve this problem by two methods, right? So the first one is the direct method and the second one is the usual method of using the trigonometric identities and the process of definite integration, right? So let us first see the direct method, right? Suppose we have an integral of this type, that is 0 to pi, and the integrand is the sine of px and cos of qx, right? Where p and q are positive integers, right? So when we come across with this type of integral, then the direct value of this integral can be written as 2p divided by p square minus q square, right? And here we have one condition, that is p minus q, that is the difference of p and q must be odd, right? So when we have the integral from 0 to pi and sine px cos qx, where p and q are positive integers, then the value of this integral can directly be written by this expression, that is 2p divided by p square minus q square, and provided the difference between p and q must be odd. So now let us apply this rule to this integral, right? So if we compare this integral with this one, then we see that the value of p is 2 and q is 5, and obviously 2 and 5 are positive integers, right? And the difference between p and q is 2 minus 5, that is minus 3, which is odd, right? So the direct value of this integral, let us call this integral as I, right? So the direct value of this integral I is 2p divided by p square minus q square. So we have 2 times 2, and p square is 2 square and q square is 5 square. So this is 4 divided by 4 minus 25, that is 4 over minus 21. So this is the value of this integral. Now let us consider the usual method, right? Now see, here we have the product of sine and cosine. So what we will do, we'll multiply this integral with 1 over 2, and here we'll write 2, and we have 2 sine 2x cos of 5x and dx, right? So here 2 and 2 get cancelled, so now we have the form 2 sine a cos b, right? And the formula for 2 sine a cos b is sine a plus b, and here we have plus sine a minus b, right? So now let us apply this formula to this product. So I can now be written as half, and we have 0 to pi, and now we can write sine of a plus b. So here a is 2x and b is 5x, right? So 2x plus 5x is 7x, and then we have sine of here a minus b. So 2x minus 5x is minus 3x, right? Okay, so now here we have the term sine of minus 3x. So from trigonometry we know that sine of minus theta is minus of sine theta, right? So now we can write half, and here we have 0 to pi and sine of 7x, and here we have minus of sine 3x, right? Okay, so now we have the difference of two integrals, right? And here we'll make use of this result, that is sine of ax, integral of sine of ax dx is negative of 1 over a, and here we have cos of ax, right? So now we can write half, and the integral of sine 7x, right? And here we have dx, and here we have 0 to pi, and sine of 3x dx, right? Okay, so now we can write half, and see, here we have minus 1 over 7 cos of 7x, and limits are from 0 to pi, and here we have minus 1 over 3 and cos of 3x, and limits are from 0 to pi, right? Now let us substitute the limits, and we'll take the difference. So we can now write half, and here we have minus 1 over 7, and when we take pi here, we have cos of 7 pi minus cos of 0, right? So when we take x is equal to 0, so cos 7 times 0 is 0, right? And here minus and minus becomes plus, so we have 1 over 3, and we have cos of 3 pi minus cos of 0, right? Okay, so now we have to simplify this expression. So now the value of cos 7 pi is minus 1, right? So here we have minus 1, and cosine of 0 is 1. So here we have 1, and here we have plus 1 over 3, and cos 3 pi is minus 1, cos of 0 is 1, right? So here we have used an important result from trigonometry, that is cosine of k pi is equal to minus 1 raised to k when k is say odd, that is 7, then we have cos of 7 pi is equal to minus 1 raised to 7, that is equal to minus 1. Similarly, cos 3 pi, because we can write cos 3 pi is equal to, here we'll take k is equal to 3, so this is minus 1 raised to 3, so this is minus 1, right? So now let us simplify this. So we have half, and here we have minus 2, so this is minus 1 over 7 times minus 2, and here we have 1 over 3 minus 2, and this is half, and this is 2 over 7, minus times minus is plus, and here we have minus 2 over 3, right? So this is half. Now we can take the LCM here. We have 21, then we have here 6, here we have 14, and now this is half, and 6 minus 14 is minus 8, and here we have 21, right? So now this is 2 4s are 8, so we have minus 4 over 21, right? And which is the same result which we have got from this direct result, right? So viewers, this is how we can solve this integral by these two methods.